Welcome to this presentation on school roofing. We've got two panelists today. My name's John Simmons. I'm the director here at Nuralite Waterproofing, and we've got Shane Clarke standing up there by the whiteboard. He's the general manager of Nuralite and has untold experience in membrane roofing. Little known fun fact, he actually trained as a PE teacher. Just looking at him, you can see he outgrew the role and is now our general manager. And we're coming from the South Island, we've got Angela Duthie. She is the technical specification manager for diamond roofing and has been involved in quite a few Tricore jobs, particularly schools down in the South Island. So it's excellent to have her joining the panel. Okay, first question is, why are we focusing on schools? Schools are about 22% of the non-residential market, so they're quite a large part of the built environment in New Zealand. And what we're seeing is, we've seen a lot of new schools, but we're also seeing remedial work coming up as old schools needing to look at what they're doing with their roofs and how they upgrade them. Firstly, for me, my memories of schools are arriving at school quite wet, covered from, walking through the Hamilton rain and frost and hanging my clothes up, jacket up, my bags, and sitting and trying to warm my hands by the radiator heater, which was probably coal-fired at that time. So really the school environment was damp and cold, or in the summer extremely hot. It wasn't actually a very comfortable environment, and to be honest, we would have trouble working in that environment here at Nuralite. I can't imagine the team would move from our present premises to a school classroom. I actually went past my old school the other day, and it was exactly the same as it was always been, as I remember it, which is tells me that these assets last for a long time. They're not being torn down and rebuilt. What we're building today is going to be around for a very long time, and so we have to have that in mind when we're looking at what we do. It's got a long life cycle. There's also been a lot of well-documented expensive failures with regard to school buildings. Tend to be around weather tightness, but also condensation issues because of, as I said, the way the kids behave inside the schools, and just having all those humans inside a school creates condensation issues, and also maintenance. I think it's fair to say they're not terribly well maintained. It's usually maintenance is done when there's a problem rather than as part of ongoing maintenance. Okay, today we are sponsoring or supporting Kids Can. So everyone who's attending today, we're going to give $10 towards Kids Can. That's a charity that is trying to lift all kids so that they're all given an equal chance to do well in life and in their education. So I think it's really appropriate charity. We're going to kick off today with a poll. I'll just bring it up now. It's just a really simple one. What is your area of interest in attending the specification presentation today? You could be a designer, a builder. We've seen people from the Ministry of Education sign up, which is great. Welcome. And there's other people with outside interests with regard to also sustainability people. So just tick that box. Oh, when it comes up, sorry. Trying to get the technology going. Just let us know what your background is. Okay. Last couple of people are still polling. So we've actually got a mix of designers and mostly others. So we have to drill down on that later. Okay, I will close that poll down. Okay. The first part of this presentation, Shane's going to run through the challenges. He's actually in front of the whiteboard now because we decided we might as well treat it like a school. Rather than actually bore you with PowerPoint presentation, we're actually going to try to make this an interactive presentation. So you can use the chat function when we're asking you to input information, and I'll be feeding that through to Shane. Also, during the course of the presentation, just use the Q&A if you have any questions, and we'll have about 5 minutes at the end for questions. Okay, Shane, do you want to jump into it?
Yeah, sure. Tēnā koutou katoa. Good morning, everybody, and welcome to the classroom. Not sure about you guys, but during COVID-19 lockdown, one of the things I remember, not that long ago, was being PowerPointed to death. So we're trying to try and mix it up a bit and read my messy writing on the whiteboard. And we're trying to make this interactive as possible. So I really want to hear your comments and whatnot coming through the QA or the chat. So what I want to do is basically list a couple of design considerations that we think you should have, and it's definitely things that we consider when designing roofs for school buildings. They have a unique set of circumstances around them. They have many occupants who will breathe out moisture. They're all hot and sweaty, or they're freezing cold. They then shut the buildings at 3 p.m. So this puts lots of, I guess, strain on the building stock from a building performance way. So I've got a couple here to start us off. So some of the design considerations we think is acoustics. Another one under occupant comfort is warmth. Warmth also relates to being cool in summer as well. So I just put that there as a bit of a trigger. Have we got any more for occupant comfort there?
Yeah, so people can, if you have any things that you want to check on, just add them to the chat and we'll add them in. But Shane, you just keep going and I'll drop them in if I see any getting added to the chat line.
Right, so under building performance, we're looking at things like condensation. Like I said, lots of people in a small confined space, creating humidity, and that warm, moist air condensates when it touches a cold surface. So that's something you should really consider in our roof design. Weather tightness, something that's probably really important from a roof perspective, especially you know, from Nuralite's position. We think the walls are only there to hold up the roof. Under building performance is fire as well. These buildings need to perform in these very extreme conditions for the safety of the occupants. Do you have any more under building performance there, John?
Well, we're actually getting loads. So humidity control.
Yeah, sure.
Which is kind of related to condensation.
Yep.
Sustainability.
Great. Let's put that under buildability.
Okay. Okay. Ventilation, air quality.
Yeah, great. Occupant comfort.
Yep. Ventilation, venting.
Venting. Yep.
Supporting PV panels.
Yeah, great. Let's put that under buildability.
Put that in
yeah.
Buildability. Okay. Well, okay.
Right. A
couple others are UV exposure, so that would be under building performance.
Yeah. Yep.
One that's very common is light levels.
Yeah, right.
So building performance, ensuring there's light occupant, yeah, however you want to put it.
These are all great design considerations for school buildings.
Ceiling height.
Yeah. Yeah, isn't it? See, I was a PE teacher by my handwriting.
Yep.
And doctor.
We've got another one, which is life cycle, which we've got up there on under buildability.
Great. Yeah, I've got life cycle sustainability right there. Yeah.
Okay. So look, if you want to, if anyone wants to add more, they're quite welcome to chuck them in. That's a pretty good list.
Yeah, that's great. Keep building that.
And yeah, I'll pass it through to you, Shane, as we go along, when we get to the end, if we add some more comments.
Yeah, sure. Okay.
I got running cost.
Yep.
Has come up.
Yeah, great.
And also, it's kind of under life cycle.
Yep.
Renewal or overlaying. We've got insulation. Insulation levels. Yep.
Yep. Put under occupant comfort. Yep.
Okay. And we'll get a couple more before we move on. Placement of services to minimize penetrations. So keeping things simple.
Yeah,
I'll put it that. Yep.
Services. Yep.
And adaptability.
Yeah, great.
Oh, wow. God, this list is getting. And the last, we'll probably have to send, we won't be able to work through all these within the 30 minutes, but ease of construction,
Yeah, right.
buildability, and also health and safety.
Oh, good to see we've got a couple of teachers' pets out there. Great.
Okay, let's crack on. Well, that's a great list. Thank you, everybody. So just so you know the format, Angela's going to talk to us about the Tricore system next. Then Shane will talk to us about Nuratherm, and then we'll come back to this list and just run through it. So, okay, let me just flick over. I've got to share my screen, and then Angela can start her presentation. Angela.
Thank you. Hi, everybody. So Tricore is a layered roof system that mitigates the usual issues with standard roofs. It's been specified for a number of education products throughout New Zealand. So each component has been selected by Diamond to provide a specific purpose, and this can be customised to stand up to the varied New Zealand conditions. And of course, we give those a 15-year warranty on all those components. So running through them, the first layer is the NPM 900. So this encloses the building quickly. It's weather secure. It does enable it to be weather secure and allows internal work to continue, and also a level working platform. This is really important for the speed of the build. Next is the Nsm Pir Insulation, sourced from Nuralite. This is compact, highly efficient, and has long-term true R values, and it's also highly compressible strength. You can add in a jib weatherline layer here or a suspended ceiling to increase the acoustic performance. Then the Solitex Mento 1000 paper and the Tricore galvanised roof rail is fixed through to the purlin. This enables vapour to permeate through, condensate on the cold side, which is underneath that top profile, and that condensation is then removed through the ventilation via that cavity created. So other warm roof systems don't allow a ventilated cavity on the cold side, so we really consider this a bit risky. And on top, fixed into the roof rail, you can use any of the Diamond roofing profiles to suit your project's design or aesthetics. So here you can see Diamond X630. So this is a clip fix system with zero penetration. So this can be rolled directly onto the roof, probably for more sizable projects, and can be manufactured up to 100 metres in length. The dual fixing system means there's no single fixing from the exterior roof directly through to the purlin. So this ensures any moisture ingress can't migrate through the roof system, and it doesn't allow additional thermal bridging from fixing movement of the top sheet from the thermal activity. Next slide. So this is a new school in Wanaka specified with Tricore. So they used a 0.55mm base tray, 80mm PIR insulation, and DP955 for the top profile and 0.55mm Tricore. As you can imagine, this region experiences the extreme weather that we have in New Zealand. The feedback from the roofer and the construction firm on this project, they commented about the speed of the build and considerable time savings due to enclosing each building quickly. This enabled a continuance of all the trades, and the remainder of the roof was installed while other people were working. So, and of course the roof system met the MOE requirements around acoustic, thermal, safety and aesthetics.
That's great, Angela. Thanks for that. Let's jump across now and get Shane to talk us through the Nuralite Nuratherm system.
Yeah, hi. Welcome back. Similarly to the Nuratherm warm roof system, the sample we have on the screen here shows a metal profile tray as the substrate. This is a lot more economical procedure. It also provides a temporary service platform for trades during construction. The Nuratherm warm roof could also be installed on plywood, concrete, or even over existing roofs, whether they be profiled metal or existing flat roofs with plywood. The next layer in the system is our aluminium vapor blocker. So this is a true aluminium foil vapor blocker. It doesn't let any moisture that rises with the warm moist air inside rise up through into the insulation layer. We think this layer is extremely important. We do know that if you do some two-dimensionally modeling and muck around with it a bit, you could potentially remove this, but for a very low cost, you do add a lot of redundancy by having this layer in there. We think it's very important and one of the things that sets us apart, I think. So the next layer in the system, similar to the Tricore, we're using the Inafune Pir Board, which has one of the lowest lambda values of 0.022 on any product available in the market. This product here allows us to have a continuous layer insulation across the roof surface. It's uninterrupted by roof structure like purlins and rafters and things like that. So I guess it's one of the concepts of a true warm roof is where the insulation is outside the structure, allowing it to be continuous. This also eliminates the condensation as well by having an effective thermal layer on top. So it stops the warm moist air rising and touching any cold surfaces. The next layer in the build-up is a double layer bitumen-based membrane system that's been tried and true tested in New Zealand for well over 50 years. The first layer is self-adhered or peel and stick, if you like it, like a sticker to the surface of the PIR board. That's then finished with a very thick, robust mineral finished cap sheet, which provides your maintenance traffic resistance, your UV resistance, and very, very easily repaired if needed. So that's basically the layers of the Nuratherm warm roof system. Being a complete a la carte system, if you like, you can add additional layers if required, like acoustic properties, or you might want a very, very high insulated warm roofs. You can add different thicknesses of PIR board. You're not simply limited to one size fits all. So it's completely a la carte and simply able to be fit for purpose, if you like. So what I'm going to show you here is a case study of a job we've done relatively recently. This project is at Howard College. So this building is a typical Ministry of Education standard H block design, of which there are probably hundreds around the country. Some of you have probably even taught in them. So this roof is approximately 40 to 50 years old. We've got a 1mm thick grey EPDM existing membrane that has done particularly well under the circumstances, we thought, 40, 50 years old. It's been skateboarded on, walked on, and had lots and lots of services retrofitted to it throughout its life. So over the lifespan, this plywood has actually slumped, creating ponding that's not ideal at all. So we see in our system here, the next layer is the vapor barrier, which is again self-adhered, peel and stuck, put down on top. That provides the building temporary waterproofing. So this allowed the occupants inside to carry on. I know that in this building they had a science block, a technology block, and a lot of their computer equipment was in this area. So enabling the school to continue to use this building during its waterproofing regime was quite useful, I thought. So the next layer in the sandwich is the PIR board. And as I mentioned earlier, over time that plywood actually slumped and created ponding water. So what we were able to do in this instance was use a tapered PIR board, which has a 1 degree fall already cut in it, therefore increasing the overall fall or pitch of the roof. We really think it's important to get the water off the roof. So that was then mechanically fixed straight through into the plywood substrate. Immediately after, there was the self-adhered peel and stick base sheet, which was then stuck to the surface of the PIR board. So what they're doing in this photo here, they're only sort of staging their construction. So they're maintaining the waterproofness of the building throughout its construction. So they're doing two things with the PIR board. They're increasing the fall, but also providing that thermal resistance or insulation continuously outside the structure. Once the base sheet's in place, we're waterproof, we're weather tight. They then come back and apply the second layer, which is the 3PM mineral finish cap sheet, providing us with a very robust finish, allowing us to sign off on that. We're very, very happy with that final roof there. So, yeah.
Thanks, Jane. Right, let's run through these design considerations, and we'll just have it as a bit of an open chat, really.
Yeah.
Either Angela or yourself can jump in.
Yeah, sure.
Firstly, up there is acoustics. Anyone got anything to say about acoustics?
So Tricore can achieve an STC of 37 on its own. You can add in, as I mentioned earlier, those acoustic layers to get an STC of up to 55 or beyond. And of course, the NC ratings have all been worked through with Marshall Day as well.
Yeah, great. Nuralite's also done some testing with Marshall Day, and we do achieve acoustic properties also. And as I said, the system's a la carte. We can add and subtract different layers to provide different acoustic properties should be needed.
Okay. Warmth and insulation.
Yeah, so by having the insulation board continuous across the surface, we achieve a much greater R value than would typically be provided. So for example, your R value of a 100mm board might be 4.5. That actually equates to an equal construction R value. Warmth for now, I guess in my interpretation, also relates to cold. So having insulation outside the structure actually stops the structure from warming up as well.
Cool. Angela, do you want to talk to us about air quality?
Yeah, so look, with air quality, you obviously want to reduce the amount of moist air in the building. So there is probably required some form of mechanical ventilation. It's not all going to be drawn out through the vapour. So I think that is a design consideration that needs to be addressed in other manners as well. You can't just rely on teachers to keep the windows open, but that's something else to think about there.
So being a window monitor will be a thing of the past.
I remember those days.
Yes. Quality job that was.
Yeah, I thought that was actually a privilege.
Yeah. For you, Shane, it was. Yeah. Okay. Let's keep cracking on. Condensation. I think that's an important one.
Yeah, so when we're talking about condensation, we're talking about humidity, we're talking about the amount of moisture in the air, and as we know, when it touches a cold surface, it condensates. We don't want this to occur within the living space, within the habitable space. So I know for both systems, using the Inafune Pir Board, it is effective and eliminates that condensation point. It's outside the structure.
Cool. What about fire? That's obviously an important one. Angela, come on.
From a fire perspective, for both systems, you can achieve up to a 1S surface fire protection, working with the engineer as well. But when you're using a suspended ceiling, it's not really required. But it can achieve that.
Yeah, great.
Light levels. What about that? Can you put a skylight in it?
Yes, absolutely.
Yes,
and with the flat roof?
Sorry, yeah, same with the Nuratherm system. You can insert solar lights or skylights, whatever you want to call them. And being a membrane, it's particularly easy to detail that penetration point. So it allows for that.
Cost.
Yeah, so cost is a big one. I guess, believe it or not, both systems can actually be more economical than an original traditional roof, particularly with a membrane on plywood example. So the example I showed you earlier of the Nuratherm system on a metal tray is incredibly economical. The speed of build is quite quick. Therefore, that's where we get our cost back. The other thing to consider about cost, particularly with school buildings, is that the MOE own these assets and have no real intention of selling them anytime soon. So, you know, a couple of dollars more upfront is really going to be cost effective, particularly when it comes through to the life cycle of the actual asset itself.
Okay. Angela, do you want to talk about life cycle? How do you renew your system at the end?
Yeah, so from a life cycle costing perspective as well, you can just replace that top sheet on Tricore. So of course, as we saw from your demonstration, you can just replace the membrane on top of what you've already got there. You're not having to replace the whole system. From a sustainability perspective, we've gone through our environmental product declaration with colour code. We've also obtained green tag accreditation, and we've got a number of programs in place to reduce our carbon footprint as well. So switching out certain products like the top profile to MagnaFlow can actually save you quite a lot in your carbon footprint.
Cool. Someone's put up their PV panels. Shane, do you have ability to do PV panels?
Yeah, so being a membrane roof, it's not doesn't require continual rainwash. It's inert, so it doesn't react with airborne dust and dirt and whatnot. So PV panels also particularly like to lie relatively flat. They don't like standing up too upright. And again, about those membrane penetrations, they're very easy to detail with a membrane roof. And we've got many examples of PV panels. The Nuratherm system even has its own accessory to make it really simple. It's a pre-assembled plate with a factory installed gasket, which does all the waterproofing for you. So we make it easy as we can. And I think PV panels are a great idea.
Wanaka School actually put some PV panels on there, and we can actually supply PVLs, so the laminates. Now they can be stuck on products like Solar Rib, which was designed for them, and also the other, probably Heritage Tray would be the only tray product you'd use with Tricore, but cost may be a consideration there. So yeah, absolutely.
Cool. Look, I've got some questions that have come through that just summing up some of those other ones. I mean, simplicity. I mean, that's actually one of the key things for membrane roofs, keeping it simple, isn't it? So there's no debate there. And health and safety considerations, obviously important, yeah. But I'll give you some questions here that have come through.
Yeah, sure.
Are the two systems compatible?
Yeah, no, that's a good question. That comes up relatively often, particularly in this, I guess, construction industry. There's a lot of incompatibility, and lots of people say he, she said, it won't, it will. We do know, and we've detailed together the diamond Tricore system with the Nuratherm system. So, for example, you're going from a steep pitch Tricore metal roof into a fully insulated gutter. That allows you to carry insulation continuously again across that structure.
The good thing with that also is that once you get that base tray down, because we're using the same base tray, it can enclose the building quite quickly. So you've got consistency of that base tray and consistency of the PIR.
Right.
We've got someone here saying that they didn't think you could use membranes on schools.
Yeah, that's a little bit of a misnomer, and been in the membrane industry for about 20 years. I have heard that several times. Membrane roofs are a restricted design works, which is outlined in the MOE's weather tightness guidelines. What that means is that a membrane roof design will have to go through an additional step in the I guess the consenting process. Now, this panel is made up of a group of industry experts who are outside the MOE, who actually have experience with these high performance roof systems. So they are aware of them, and they know that they have code mark and brands appraisals and whatnot, and so it's not new to them.
Okay. Just doing a couple more. Someone's expressed surprise that the ministry will consider whole of life. So that's just a comment that someone's made, but personally, as I say, my school's still standing, and it hasn't changed much. So yeah, one would like to think that they start raising their eyes a wee bit and kind of considering it whole of life.
I think it's becoming more and more critical around that maintenance piece as well. It's pretty clear that schools perhaps haven't prioritised this, so it's important they get a system that's actually going to require little maintenance, but really serve for the long term as well.
That's a good point. Robustness and durability is a key consideration. Yep. Someone's asked, what's the warranty on the overlaid membrane roof?
Yeah, right. So the example we showed you with the Howard College overlay, if you like, everything we did there was in the scope and limitations of our code mark certificate. Pretty run-of-the-mill stuff. So we're able to give that a 20-year warranty.
Okay. We're coming up to almost 30 minutes. I've got one more question here. Comparison to insulated panel systems. That's probably one for you, Angela.
Yeah, so look, the likes of those sandwich panel systems are actually imported. So they're limited to the size of the container. So they'll be about 11.4 metres in length. With that, you're going to have a lot of side and end laps. You're really relying on workmanship there. And we see that as quite a risky situation. So with our system, you can run full lengths. So there really is no risk. And even further, if you go with that clip fix system, you're not going to allow any penetrations there as well. So they have their place, but I think that workmanship certainly has a limitation there at times.
Cool. Look, what we'll do is I'll run a quick poll now. I mean, we are seeing some other questions coming up. We'll run a quick poll. I'll wrap up so anyone can leave if they want to, because I'm conscious that time's important. We can ask a couple more questions at the end, see if we keep going. So the quick poll, relaunch polling. I'm sorry if I'm, where's our next poll? Oh, okay, so we'll drive this one. So we just, again, we wanted to continue the school theme, and we wanted you to give us it's not an NCA mark, it's a traditional mark. So yeah, if you could just give us a score for the presentation, I'll give you some wrap-up comments. Firstly, we've been recording this presentation during the course of it, and so we're going to load this up onto our website in a couple of days. We'll also send you around a list of all the questions and the answers, and we'll run through these key components that we've come up with. Via email. We have a page on our website which is an education page, and you easily find a link to it. That's where the recording will be stored, but it's also where we've got our upcoming webinars. So if you like this one, which we're pleased to see, we've even got some A+, which I never saw when I was doing school. If you enjoyed yourself today, the next one come out is actually going to be focused on tapered boards, which actually is similar to that Howard College, but we'll actually take you through in quite detail, and we'll have our computer guru here showing you how he actually does the tapered board plans. And then after that, we'll be looking at how to reduce your carbon footprint during the re-roofing. So rather than actually demolishing, how we actually raise our the quality of the built stock by re-roofing with a quality system. Okay, I'll end that poll. Thank you very much. And we've got one last poll. This is just an opportunity for you to just say if you'd like us to do a follow-up, give you a call, come around and run through a project with you. We'd be delighted to go into more detail. Okay, I do see one of the things people talk about is venting. So do you actually vent the roofs, Shane? Because, you know, obviously with a traditional roof, you have to vent it.
Yeah, that's right. So a typical, what we call cold roof, which is just a membrane on plywood, you need to vent for the warm, moist air that builds up inside the structure. You don't necessarily need to vent for the purpose of the membrane. It's all for the structure underneath. So with the warm roof and the continuous layer, excuse me, we can edit that out. With the continuous layer of PIR board, we're stopping that warm, moist air rising and touching a cold surface. So this eliminates the need to vent through the roof. However, we still need to maintain that air quality. And like Angela touched on before, now we've got a high performance roof, this air handling unit that's taking the old stale air out, bringing the fresh air in, can work a lot more efficiently. So don't vent warm roofs, yes.
Cool. We've got a question here from Sue. It's kind of a comment, which I can actually answer. It'd be great if weather tightness could be monitored without having to go to the roof. Yeah. Some sort of sensors to monitor moisture within the structure, perhaps. I mean, those systems do exist, and you can actually have wireless ones. I mean, they're not cheap to install at the first place, but they do the trick. Our experience is actually with membrane roofs is it sounds like I'm skyding, but they don't tend to leak. Once they're done, they're very robust, and during the two-layer system, we don't actually see problems with them during the course of their lifetime, unless there's some mechanical damage. Someone goes and puts a sky dish through them or something like that. Okay, Paul has said, what support do you provide for designers with tricky detailing? Shane, what do you got to say to that?
Plenty of support. So you get hold of us many ways. We're obviously on phones, and we've got little attachments on the bottom of our email signatures you can zoom through. We have a live chat feature on our website. One of the benefits, I guess, with these particular membranes is we're not constrained to the confines of E2, so we can come up with all sorts of tricky details, and we've got 50 years of case studies of all sorts of tricky details that can be solved with a combination of membrane detailing and the accessories that come with the system. Okay.
Joel has asked, if you have an existing metal roof, are you able to use that as a substrate?
Yes, in some situations you can. It'd have to be pretty well intact, and it would depend on the profile as well, so it would be a case-by-case basis.
Yeah, and equally with the Nuratherm system too, we see a lot of re-roofs of older metal roofs, particularly new roofs that need to be repitched. By putting the membrane over the top, you eliminate the need to repitch the roof. So,
we've had a question here. How does the membrane absorption of surface water, how is that dealt with?
Okay. It's not dealt with because I guess that the membranes we're using are very modern in technology, although we're saying bitumen, and bitumen's been around for 3,000 years. These are actually modified with a tactic polypropylene plastic, which goes into the mix and eliminates that moisture absorption. So we actually do have testing to show that modified membranes are extremely low water absorptions, below 0.01%. So we don't have that issue with our membranes. I know that it is a phenomenon with other types of membranes. One of the reasons why we stick by the double layer bulletproof 3PM system.
Okay. And what's the minimum fall?
So for us, the minimum fall is a final finished fall of 1 in 80. We recommend you design at 1 degree.
Cool. And I've just got one more question before we wrap up. It's around certifications and sustainability credentials. Shane, what certifications do you have?
So the system has a code mark certificate. It's also brands appraised if that's to your liking. We try to appeal to both audiences, and Nuralite itself also certified carbon zero.
Okay, and Angela?
And so from a diamond Tricore perspective, you get a 15-year warranty on all the components, and of course you've got the brands appraisal of the Inafune Pir Insulation plus the Mentor 1000 paper in there, plus all our sustainability accreditations as well.
Cool. Okay, well, let's wrap it up there. Thank you for everyone for your responses and for your participation. We've got a huge list to document and send back to you. And we've really enjoyed giving this presentation. We'll be back in about 2 weeks' time to do one on tapered boards. Thanks very much.
Thanks. We'll see you there. Cheers. Bye-bye.
Bye.